Hello and welcome back. This is question paper 3. This is question paper 3 2003. Session May and June 2003. This is an IGCSE also. Okay, so now let's work with the question 4 now. Question 4 here we have reflection, translation, enlargement, rotation. So here the use of tracing paper is strongly recommended for the rotation. Reflection could be for first and second and third one is important, but especially for case of rotation or rotate, it's important to use the tracing paper. Now draw accurately the image of triangle T under the following transformations. Okay, triangle T. So we are going to work with triangle T, this triangle T here, and we have to do some translation. Type. So translate triangle T by the vector -3 and 4, label it P. Okay, translation by the vector -3 and 4. -3 and 4, it means going to left 3 steps, going up 4 steps. That's mean the first component is x, the second component is y axis. So -3, it means -3 left from each vertex and go up 4 steps from each vertex. So this is the vertex here. So here, this vertex, you should move it -3 steps. That's mean here. Then go up 4 steps. So 1, 2, 3, 1, 2, 3, and 4. It will be here. You will do the same for all of these vertices. You should do the same. So again, this vertex, the blue one, 1, 2, 3, 1, 2, 3, 4. It will be here. Now for another vertex here. 1, 2, 3, 1, 2, 3, 4. It will be here. Last one, 1, 2, 3, 4, 1, 2, 3. It will be here. So now you can connect these points together and make a triangle T. But this is a new image, so we have time. For sure you have to use your ruler drawing the sides, so and label it P. So this is P here. Here we have it P. Now we finished with I. Now let's move to reflect triangle. Reflect triangle T in the line x equal 8. So we have a mirror line or line of reflection. X is equal to 8, so here is x-axis, 8 is here, so x equal 8, that means whatever y is, always x is 1. So here we will draw a mirror line or a line of reflection or reflection line. So here you can draw it. I will use different colors. So here 8. So we have a vertical line go through point 8. So this is x equal 8. Now reflect it, it means from each vertex here, a distance from this vertex to the mirror line is the same distance from the mirror line and the reflected point. So it will be here. So here we have 1 step. So after reflection line we'll have 1 step. So it will be here. Same for this vertex. 1, 2, 3, 1, 2, 3. Full step and full square. Full step and full square. Be careful. So once you are counting the steps, do not count it like 1, 2 in the middles or quarters. No, 1 full step. And the last one, 1, 2, 3. 1, 2, 3. It will be here. So this is the reflected triangle. This is our reflected triangle and label it Q. So here we'll name it Q. So here we have it Q. Okay, now rotate triangle T about the point A through 90 degree anti-clockwise, label it 4. So the same one in here, T, we will rotate it anti-clockwise. We will rotate it anti-clockwise. So in this case, in here, the center of rotation is the same point A. So A will be rotated at the same in the same place. So point A will be rotated at the same place, So here A, anti-clockwise. So again, from each vertex, you have to rotate it. So this vertex still have this vertex, anti-clockwise 90 degree. Anti-clockwise 90 degree, you will get it here. Now, a tracing paper, as I said, strongly recommended. This one here, according to A, which is 90 degree, we need to rotate it 90 degree. 90 degree with A, it will be this position here. It will be rotated here. 90 degree. That's mean if you draw, this is 90 degree here. You see? So please work with the tracing paper. Work with the tracing paper. So this is our rotated shape, and we will label it R. So here we'll call it R. Now, enlarge triangle T with center of enlargement A and scale factor 2, label it as here. Enlargement, that means each length of this triangle should be extended. So enlargement center is A, so we'll use the same enlargement A here. A, it's our enlargement, center enlargement, sorry. Now, from this point, it will be the same for sure. As you can see here, this side here and this side here are 2 steps. That's mean the scale factors are 2. That's mean you should multiply this length by 2, you will get it 4. So distance here will be 4 steps. 1, 2, 3, 4. It will be here. Same for this length here. It's a 1 step. Multiply 2, it's 2 the scale factor. So we'll go up 2 steps. So it will be here. So now you can draw. Actually, you can draw it. Tracing paper also help you using this to enlarge triangle here, and label it S. So this is S here. Yeah. Now this is an enlargement. We finished it. Now describe fully the single transformation which maps triangle P into triangle T. So you have to get back and read triangle P into triangle T. As you can see, from P to T, so we are going back to our original here. So here, as you can see, it's 3 steps to the right and going down from this point here. 1, 2, 3, then 1, 2, 3, 4. So minus 3 to the right and minus 4 down. So it's translated by the vector 3 and minus 4. So here you should get back and write a translated shape or translation with a translation with vector 3 and minus 4, or translated by shape by the vector 3 and minus 4. Translate S into T. S into T here, enlargement S into T. That means you should first identify the name of the transformation. So from S to T, it's enlargement. This enlargement has a scale factor. You should also mention the scale factor. The scale factor old one dividing by the new one, which is 1/2. So the scale factor is half, and the center is same point A. So we should write this on our question here, on our answer, sorry, here. So we have to write it here, and we have enlargement and with a scale factor 1/2 with center A. Important, these 3 points: the name of the transformation, the scale factor, center. Rectangle DEFG is rotated into the rectangle KLMN with D map into K. Write down the angle of rotation. Go back here, DFEG, DEFG, this rectangle rotated into another rectangle which is KLMN. So this rectangle, it's clear, it's a 90 degree from each vertex to each point. It's clear, 90 degree. So here rotation 90 degree. It's clear also here, as I said, it's DK, DJ, it's perpendicular to KN, so it's a 90 degree for one of each of these. The center must be the same distance from K as it's from D, so we have the same distance. For this, tracing paper will help you also to reflect this shape, and the map is clear from D into K, from D into K. 90 degree. And now the coordinate of the center of the rotation. The coordinate of the center of the rotation is here clear. We have found it here because they are mapping it from D to K, from this D to that one up K, which all point is here 3 and 3. So center of rotation is 3, 3 x-axis, 3 y-axis. Okay, now let's move on. Question 6 here. Question 6 is about area. Okay, so in the diagram above, all the angles are right angles. Okay, show the area of the shape is 13.5 centimeters square. Here you can divide this shape here in this way, or you can divide the compound shapes to be these shapes here. Okay, so you can find the area for this rectangle, add it to this rectangle, add to this rectangle, and then find the area for these two rectangles here, add them up, you should get 13.5. So here let's do the green one here. So here we have 2.5, so 2.5 times a length here, the length that we have it here is a 1, times how many rectangles do we have here? We have 3 rectangles, so 3 times 2.5, 15, 7.5 centimeter square. This is the area for the first 3 rectangles. For these rectangles here, we have here 3 centimeter, and here for sure we'll have 2.5 minus 2.1 is a 1, so 3. We'll have an area here 3 times 1, which is 3, and times 2, you will get 6 centimeter square. Add it to 7.5, you will get 13.5 centimeters square. So the idea is easy. First, find the area for this rectangle here, for this rectangle here, for this rectangle here. And lengths are easy cleared. This is 2.5. The width here we have it 1 centimeter. And so, and also for this, and same for the these two rectangles here. This is already given, which is 3 centimeter, and here clear someone 2.5 minus 1.5. So answer here will be the answer here will be 13.5 centimeters square. We proved it. Yeah, this one, sorry, this one here and this one here, and then with 13.5 centimeters square. If you want to organize it more, so for sure you should organize it, but it's clear, so you can do it. It's okay. So we can write it here as area equal 3 times 1 times 2, because we have two rectangles, plus 2.5 times 3, for sure, times 1 length. So here we'll get 6 here, plus 7.5, which is 13.5 here, sorry. So the shape is the cross section of a metal prism of length 2.8 meters. Calculate the volume of the prism in cubic centimeters. Counting or calculating the volume, it means the area of the cross section that you have, and we have it here 13.5, which is equal 13.5 times length. In length, it's clear from the question itself, it's given with the length 2.8. Using calculator, you will get 3,780 centimeter cubed. Now, a metal cuboid is melted down, so the prisms as described in part B can be made. The cube measures 2 meters by 1.2 meters by 0.8 meters. Calculate the volume of the cuboid in cubic meters. Calculating it in cubic meters is easy. So it's 2 times 1.2 times 0.8. It's important to mention this, that you were finding the volume, and it's like equal 2 times 1.2 times 0.8 using the calculator here. It's a 1.22 meter or cubic meter. Now calculate the volume of the cuboid in a cubic centimeter. Centimeters, you have to change it. You have to change it to be a meter. So each length here, you should change it. So volume, you should change it to meter, so to centimeters. So this is 1 centimeter is 100 1 meter to 100 centimeters. So we have here 200 centimeters times 1.2. 1.2. It means multiplying by it 100. You will get 120 times. Here also you will get 80. So we have 3 zeros or 4 zeros, and the same answer as in here. That's mean if you want, you can multiply it here by 1 million. Yes, you will get answer 1, 2, 2, and 4 zeros. Yeah, because 1 meter here, 1 meter equal 100 centimeter. We have m to the power of 3. That's mean 100 times 100 times 100. You will get 1 million. Yeah. Calculate the number of prisms which can be made. Calculate the number of prisms which can be made. How many volumes? So we have to divide. So in this case, calculate the number of prisms which can be made. So volume here, we will use volume centimeter cubed here, and we have here centimeter cubed. So dividing them 1 2 2 zeros here, dividing 3780, dividing them, you will get 507. You will get 507. 500 is the number of prisms which can be made. Draw the lines of symmetry of the shape on the diagram above. On the diagram above, we have to draw a symmetric line. So I will clear everything here, and yeah, so it's here, clear here. But you have to use your ruler, and you have to be careful that you have to middle point here. Yes, this is the line of symmetry here. It's for sure describe the rotation symmetry of the shape above. So if you, as you can one line of symmetry, that means you have at least one rotational symmetry. So here now, so here we have order 1, because any shape has a rotation with 360 degrees, so 1 order. Next now here, here we have temperature and time. This graph, temperature and time. So first of all, you have to understand the scale here. The scale from 0 to 2, that's mean 1 2 3 4 5, so 2 dividing 5 here. It's important to understand each square equal to what. So 2 dividing 5 equal 0.4. So here each one is 0.4. So you could write here 0.4. 1 second. 0.4, 0.4, 0.8, 0.8 for 1.2, 1.6, and 2. Also, we have to understand here again, please. Okay, so here is no more than 0. So 0. That means this one here up to here it's 0.4. Then we have 0.8. Then we have 1.2. Then we have 1.6. Add 0.4, you will get 2. Also for here, so 10, we also have 5. So each one is 2. So 2, 4, 6, 8, 10. This is the first step. Now we can start doing the question. The graph shows the temperature of a cube of tea cooling down in a room. So cooling down. So here they are asking us to find the temperature. What is the temperature of the tea after 0 minutes? It's clear, 84. Yes, here. What is the temperature of the area after 0 minutes. After 0 minutes, as you can see, 80 from here 0. This is 0 time. 0 from here. 0. Now going up to reach 80. After 80 we have 2 squares. That's mean plus 2 plus 2. So 84. So here we have 84. So here we have 84 degree. Now after 20 minutes, here, after 20 minutes we will check it now. After 20 minutes, which is this part here, sorry. This part here, we will reach it here, 20 to here. So it have 22 degree. Now after how many minutes is it temperature temperature 30 degrees Celsius. After 30 degrees Celsius we will start writing or drawing a line from 30 temperature, and we will see, and we will touch it with the graph, and then we should go down. Yes. So here we have 10 plus 0.4 plus 1 plus 11. Here. It's not on the same in the touch, yani. What I mean it here, what I mean it in this line here. If you continue, yeah, once you are drawing it on your paper, you will find it. Accurately. That's mean the intersection point is here. Okay. No. Intersection point is here. Almost here. Sorry. Even more, yani. Even more. This is here we have 0.4, and here we have 1.2, and here we have 10. 1.2. It seems the point here more than. So quarter. So you don't have to, yani, approximate it. It will be 11.2. No, 11 point. Sorry. Here is 0.4 and 0.8. Here 0.8 and almost here. Yes, it's my mistake. So here you can add more 0.2. It seems half of 0.4, so you will get to 1. So 1 plus 10 is 11. So here you will get 11. The answer here with the temperature 30 is 11. Yeah, I will explain it once more. Yeah, here. Yeah, up to here. Now. Yeah, almost here. So we have here this square we have it here, and we have this square here, and almost if you continue drawing the line here, we'll cut it in this point, at this point here, almost halfway in this square, and we said this square here is 0. Each square is 0.4, half of it is 0.2. Now this here, from here to here is 0.4. Now 0.4 and 0.4 here will get 0.8. So 0.8 and 0.2 it will be 1 almost. So 11, because here we have it. If you go down, you will see it 11. 10, sorry. Here we have it 10. So to reach this point here, it will be 11. Yes, it's like this. Now, by how much has its temperature gone down between 4 minutes and 8 minutes? 4 minutes and 8 minutes. 4 minutes, it's a 52. 4 minutes 52. Well, 8 minutes is 36. So 52 minus 36. 52 minus 36. The idea is easy here. From 4 minute time, go up to graph time. Here you will find it 50 plus 2, as we mentioned it here. 50 plus 2 is 52, so here we have 52. And for 80 also going up here, you will find it 36. So 50 and 36, subtract them, you will get the answer 16 degrees. Yeah, so 52 minus 63. Yes. 36, sorry, 36. Now complete the temperature down here from 0 to 4. You for sure you will find it as follows. You will find it 32 here, you will find it 16, then you will find it 8, then 4. What pattern do you notice about these falls in temperatures? Falls in temperatures and going down, it means you are halving. You are halving by halving, which is dividing by 2. So dividing by 2. Now estimate the room temperature. Estimating a room temperature, it depends on the graph itself. So going back to your graph, you will find it 20. So here we have 20 degrees Celsius. Now last question here, it's a diagram 1, diagram 2, diagram 3, diagram 4. So first one you have 3 dots and 1 triangle, 4 dots, 3 triangles, 5 dots, 6 triangles. It's like a sequence questions. So here we have to complete the table here, complete diagram 4 to continue with the pattern 4. As you can see here, we have 4 dots, then 3 triangles, 5 dots, then 6 triangles. Here we have to position diagram 3, then plus 2. For instance, this is the diagram 1. This is diagram 1. To make it 3, add 2. Diagram 2, add 2 plus 4 equal 4. 3, add 2, you get 5. 4, add 2, get 6. 5, add 2, get 7. Up to reach n diagram, or diagram number n plus 2. So n plus 2. Complete the table below. Completing a table below, as you can see here, that's mean one is 1, 2 is 3, 3 is 6, 4 is 10, 15. 5, here we have to find 5. So here we can find it as follows. Three minus one is 2. 6 minus 3 is 1. Yes, 2 times 3 is 6. No. 3 plus 3 is 4 plus 6. Okay. So this here we'll have 2 plus 1 is 3. 3 plus 3 is 6, which is triangular. A triangle numbers. 4 plus 6 is 10. 5 plus 10 is 15. 6 plus 15 is 21. So keep going till you reach 10. So you have to find 7. 7 21, you will get 28. 8, you will get 36. 9, and 8 36, and 9 you will get 45. Yeah, plus 10 you will get 55. So 10, it will be 55 number of triangles. Now move on to part D. Part D here, finding in part D, a line is now drawn inside each of the diagrams as shown below. Okay, how many triangles are there in diagram 3? Extra lines, that means you are doubling the triangle. That this one is doubling the triangle. It's not half, but doubling it. That means you originally you have one triangle. If you draw a line like this, that means you are doubling one triangle here and one triangle here. So you have one blue and one green. So you have 2 triangles. Here you will have 6 triangles. 2 triangles, 6 triangles. In diagram 3, how many triangles are there? We have to give some progression here. Okay, so here we have 6. It's not a doubled. Okay, yeah, doubled. It was this one here. So 1 2 3. So here 1 2 3 4, the biggest one like this. 4 5 6, the biggest one 7 7, yeah, 8, and these smalls 9 10, again 1 2 3 4 5 6, then 7 8 9 10. No. So here we have 1 2 3 4 5 6, and this one here 4 5 6, the whole one is 7 8, and this is 9. Same you will do 10, 11. So 11. Thank you all. Please feel free to write any comment and ask me for further clarification. Thank you very much all.